Today we have two main topics. The first one is combination sampling without replacement. Sometimes it's also called combination without repetition. Second topic is combination sampling with replacement. Sometimes it's also called combination with repetition. Okay, first I will introduce the concepts and then we'll practice with concrete examples. Okay, first let's see the definition of combination without repetition. Combinations gives a number of ways x elements can be selected from n elements. The notation used to denote the total number of combinations is Cnx or brackets nx or Cnx. There are three ways to denote the combinations. Well, in this book or in this class, we usually use this notation. However, if you see the second or the third notation in other books, actually they are the same thing, right? Means to draw x elements from n elements and to see how many ways can it be done. Okay, Cnx is often read as the number of combinations of n elements selected x at a time. Note that some calculators use R instead of X. That means some calculator may write the symbol as this, CNR, or brackets NR, or CNR. They are the same thing, right? If it uses letter R instead of X, it then read as the number of combinations of n elements selected R at a time, right? Any questions? So now we have learned CNR and PNR. What's the difference between these two notations? PNR means if we have a box of n distinct elements, and we pick R elements out, line them up, make arrangements. How many ways are there, right? And we have already know PNR is n factorial divided by n minus R factorial. Okay, what does CNR mean? It means we have a jar of n distinct elements. And now we pick R out of the n distinct elements. But this time we don't line them up. Once we pick R out, the task is over, right? There is no order here, no order. Remember, this is very important. So the question is, what is CNR actually? What actually is CNR? How to calculate CNR? Any thoughts? Okay, to calculate CNR, we can think this way. Actually, the PNR, when calculate PNR, actually there are two steps to calculate PNR, right? Okay, the first step is to pick R out of n. The second step is to arrange the R elements, right? These are the two steps when you do P and R. The second step is also called a full permutation. On R, right? So if you finish that, if you use two steps to finish this task, according to rule of product, how many ways are there? It is the number of ways in the first step multiplied by the number of ways in the second step, right? So how many ways can it be done in the first step? Pick R out of N, that means CNR, right? CNR is number of ways you pick R out of N, right? So this is the number of ways you can finish the first task, and multiplied by number of ways you finish the second step, which is R factorial, right? Because it is a full permutation on R elements. And the result is, because we are doing a permutation, so the result is actually PNR, because we are now calculating PNR, right? So from this equation, we can easily get CNR is actually PNR divided by R factorial. This is a formula we use to calculate CNR. Do you understand? Or you can expand it as n factorial divided by n minus R factorial. This is PNR, right? This number divided by R factorial. This is the equation we use to calculate CNR. Okay, any questions? Okay, we'll make a summary. The number of combinations for selecting X. Okay, here we use X instead of R, okay? So there's no R here, we use X here. So the number of combinations for selecting X from n distinct elements is given by the formula Cnx is n factorial divided by x factorial divided by n minus x factorial, which is actually Pnx divided by x factorial. Any questions? Okay, please write this down in your notebook, in your diary. It's very important. Okay, of course, there are some special cases. First of all, what is the number of CNN? CNN is actually 1. Why? Because what CNN means, you pick n elements from a jar of n elements. How many ways can it be done? It's actually only one way, right? Which is to pick all of the elements out. So CNN is always 1. Or you can use the formula. CNN is actually Pnn divided by n factorial, right? Pn is n factorial divided by n factorial is also 1. Okay, the second special case is Cn0. That means you have a jar of n elements. You pick 0 elements out. How many ways can it be done? There's only one way, right? Which is to pick 0 elements from the n elements in the jar. Or you can use a formula to calculate this. Cn0 is Pn0 divided by 0 factorial. Okay, Pn0 is n factorial divided by n minus 0 factorial. Okay. Can also get 1. You understand? Any questions? Okay, these are the 2 special cases. Please remember and understand. Try to understand it, okay? Okay, these are actually the abstract concepts. To help you understand this concept, we'll set some examples for it. Okay, let's see the first example. I'll guide you through, okay? And then you can independently do others. Okay, the first example. An ice cream parlor has 6 flavors of ice cream. Christian wants to buy 2 flavors of ice cream. If he randomly selects 2 flavors out of 6, how many combinations are possible? Okay. In this problem, actually, there are 6 flavors in the box or in the jar, whatever it is, 6 flavors, right? And the person wants to buy 2 flavors of ice cream. That means 2 flavors is picked up. And the question asks you to calculate how many ways can it be done. This is a perfect model of combinations with repetition, right? You pick 2 elements from 6 distinct elements. How many ways can it be done? It's actually a combination. Combination 6, 2 means pick 2 elements from 6 elements, which can be calculated using our formula, right? Formula is CNR is n factorial divided by n minus r factorial, So C62 is 6 factorial divided by 6 minus 2 factorial, 2 factorial. Okay, and we can simplify. We do not calculate 6 factorial because when this number is very large, it's not very easy to calculate. So it's better to simplify first. Okay. Okay. These 2, if we simplify these 2, you can have 6 by 5 here, and divided by 2, you have 15, right? So in summary, there are 15 ways of choosing 2 flavors out of 6 flavors, right? Okay, any questions? Any questions? No? Okay. Let's see another example. I'll give you 2 minutes to complete this. 3 members of a jury will be randomly selected from 5 people. How many different combinations are possible? Okay, you got 2 minutes to finish this. And then I'll ask a student to explain, all right? Okay, did you finish? You'll ask a student to explain the reasoning behind it, right? 方泽 方泽 Kevin, are you still there? 方泽 Okay. 黄永岩
Yes, I'm here.
Okay, can you explain this question to other students?
Yeah, sure. Because they randomly select from 5 people, and so the n equals 5. And because there are three numbers, so x equals 3. So the equation is 5c3 equals 5的阶级怎么说
5 factorial.
？5 factorial divide by 3 factorial and 5 minus 3 factorial.
Okay, thank you. To help you understand, I draw a diagram here. Actually, this problem is you draw 3 elements from 5 distinct elements, right? It's a typical model of combinations. So the result is C5, 3 means 5 factorial divided by 3 factorial, 2 factorial. Okay, simplify this, you have 5 by 4 divided by 2. And the final result is 10. Okay, any questions? No? Okay, if no questions, we can move on. Okay, another example. Marvin Sons advertised to hire a financial analyst. The company has received applications from 10 candidates who seems to be equally qualified. The company manager has decided to call only 3 of these candidates for an interview. If he randomly selects these 3 candidates from the 10, how many total selections are possible? Okay, again, I will give you 2 minutes to finish the task. And then we'll discuss the solution, okay?
老师，我有个问题，
OK，
那个 C 和 P 之间那个 no order 是什么意思？就是没有顺序，选取的没有顺序吗？
对 ，C 的意思是你从框里取出来就结束了，不用把它们排成一列。
好的。
Okay, have you finished? Okay, so this problem basically asks you how many ways can it be done to choose 3 elements out of 10 different elements, right? So according to combinations, the result will be C 10 3, which is 10 factorial divided by 10 minus 3 factorial. 3 factorial. Okay, simplify first. That is 10 by 9 by 8. 3 by 2 by 1. Okay, simplify again. The final result is 120. Okay, any questions? No? All right. Next example. Jones is the chairman of a committee. In how many ways can a committee 5 be chosen from 10 people, given that Jones must be one of them? Okay, pay attention here. There is a slightly difference than the previous 2 questions. Okay, again, I'll give you 2 minutes to think about this question, and we will discuss the solutions. So. All right, have you finished? Okay, I'll give you the solution, okay? Because Jones here is already taken or already chosen. So we need to choose another 4 persons from 9. That means the question is converted to a question that to choose from 4. Choose 4 elements from a jar of 9 different elements, right? So according to combinations, result is C94, which is 9 factorial. 9 minus 4 factorial. 4 factorial. And by simplifying, you get okay. 126. Okay, any questions? No? All right, if you have no question, we can move on. Next one. From a group of 5 women and 7 men, how many different committees consisting of 2 women and 3 men can be formed? What if 2 of the men are feuding and refuse to serve on the committee together? Okay, you have 5 minutes to complete this question, and then we will discuss the solution. Okay, have you finished? Okay, again, I'll draw a diagram to help you analyze this question. Okay, we have a group of 5 women and 7 men. So 2 tasks here. First task is to draw 2 women and 3 men without any restrictions, right? So we can use rule of product because to finish this task, there are actually 2 steps. So first step is to choose women. That means you have C5-2 number of ways, right? Okay, the second step is to choose man, which is C7-3 number of ways. Okay, if you calculate this number is 5 by 4 divided by 2. This is a 765. Okay, it's actually 10 by 35 means you have 350 total number of ways to finish this first task. Okay, for the second task, okay, this is the first task and second task. Second task, you also want to choose 2 women and 3 men from 5 women and 7 men, but with a restriction that 2 of the men cannot be together. Not be together. Okay, this is your restriction. So under this restriction, how many ways can it be done? To finish this task, you also have to do 2 steps, right? So first, we choose woman because for women there is no restriction. So the number of choosing women is also like what we did in the first question, which is C5-2, right? Okay, the key is to calculate how many ways you can choose a man now. Because now we have the restrictions, which is 2 of the men cannot be together. So we can use the total number of ways we choose men minus the ways in which 2 of the men are together, right? If 2 of the men are together, the remaining task is to choose 5 men from to choose 1 man from the 5, right? So use C7-3 minus C5-1. This is the number of ways we choose man now, right? So we multiply these 2 numbers, and now this is a total number of ways we can complete the second task, which is 10 by 35 minus 1, which is 300. 300. Okay, do you have any questions? Detailed analysis and solution can be found on the next page. And you can download the lecture slides from Google Classroom. You can read it after class, okay? All right, let's move on. Another useful formula is CNR equals to CNN minus R. Now we think why this happens. For example, C5-2 equals to C5-3, or C4-1 equals to C4-3. This is also a very useful formula. Why? Because let's think this problem in this way. Suppose we have n elements here. Okay, CNR means how many ways you can choose R elements from the n elements, right? Suppose this is R elements. So the time you choose R elements out of the n means at the same time you choose the remaining n minus R elements out of the n, right? So the number of ways you can choose R elements from the n means at the same time you can choose n minus R elements from the n distinct elements. So these two numbers should be equal, right? Okay, I'll explain it in Chinese again. 为什么我们说左边和右边相等呢？因为你想啊，从 r 个元素，从 n 个元素里边取 r 个，我每取 r 个，是不是相当于把剩下的 n 减 r 个也取出来了？每取 r 个，比如说我从框里拿出来 r 个，是不是相当于取出来 n 减 r 个留在框里了？所以你从 n 个里边取 r 个的数量，是不是就相当于等于从 n 个里边取出来 n 减 r 个的数目啊？这两个是不是可以画等号？对不对？能不能理解？Okay, any questions? So why is it useful? Because, for example, when you want to calculate C54, usually for me, I'll just calculate C51. For C51, you don't have to use a formula, right? Because simply it means to choose one element from 5, how many ways can it be done? By intuition, we can easily find that the result is 5. Why is 5? Because there are 5 ways to pick one element out of 5, right? Sometimes you use this formula sometimes this formula can help you to simplify your calculation. So just remember this and write it down on your journal, okay? Okay, so far we have learned that combination without repetition. That means we choose R elements out of n distinct elements, and we do not put any elements after we picking the R elements, right? That's called sample without replacement or combination with repetition. And similarly, there is always another problem, which is when we pick an element from the n elements box, we automatically add the same element in the box, which means we always keep n elements in the same box, right? So in this way, how many ways can it be done? Okay, I'll give you 5 minutes to think about this question. Okay? Give you some hints. For permutations, okay, if we do permutations with replacement, without replacement. Okay, permutations without replacement means we pick R from N, line them up, and we do not replace anything here. The result is PNR, which is N factorial divided by N minus R factorial. Okay, if we do this task with replacement, which means for each element we pick out of the n, we replace or we add a same element into the n element basket. The final result is n to the r's, right? Why? Because it comes from rule of product. You pick r elements means to do this task, there are steps. In each step, there are n unique ways to finish it. So the total number of ways is n to the r's. So similarly, for combinations, we also have the same question here. If combination without replacement, we have already studied this problem, right? That means you pick r from n, but this time there is no order. At the time you pick out the r elements, the task is over. So the result is CNR, which is PNR divided by r factorial, which is n factorial divided by n minus r factorial, And the second problem is, if we do this task with replacement, what the result should be, which means we pick r element from the n element box. For each element we pick, we replace this element into the box, which means the box always contains n elements, right? So here, there is no upper limit for r, but there is indeed a lower element, lower boundary. R is more than or equals to 0. Here R is between 0 and n. Here R is between 0 and n. Here R is above 0 or equals to 0. So in this case, the question is, in this case, how many ways can it be done if we draw r elements out of the n element box? And for each element we draw, we replace the same element into the box. Okay, I'll give you 5 minutes to think about this problem. Okay, any thoughts? Any thoughts regarding this problem? Okay, I'll give you explanation to this problem, okay? Okay, I'll draw a diagram to illustrate the analysis of this problem. So basically, this problem is to draw R elements from the n distinct elements and with replacement. R is above or equals to 0. So firstly, I'll draw a diagram. Okay, suppose we use sticks to represent some little rooms. Okay. Why do we use this? What do we use this for? We use the first room. That's a space, right? We use this space to represent whether the first element was chosen. Does this make sense? And use the second space to represent whether the second element is chosen. Okay, etc. For the third space, we use it to represent if the third element is chosen. Okay, the last space means if the nth element is chosen. Okay, so you can imagine how many spaces are here. Would be n spaces, right? Because we'll use this n spaces to represent whether each element was chosen when you choose R from the n, right? So how many sticks, how many walls are here? If you have n spaces or n rooms, how many walls are here? Should be n plus 1 walls, right? Because for each room there are 2 walls, but 2 rooms share the same wall, right? So you can count from the diagram that would be, if you have n spaces here, you will have n plus 1 walls. Okay, so now we can choose. Examples are, for examples, one possible result could be, okay, for our first pick, if the first element was chosen, then we denoted use a circle. Okay, for our second pick, if the first element is also chosen, then we put another circle. Okay, for our third pick, if the first element is chosen, we add a circle, right, etc. And then when you finish picking, the pattern will look like something similar here, right? Okay, this means, okay, if you have this pattern, that means the first element got picked 3 times. The second element got picked 3 times. The third element got picked 4 times. The fourth element got picked once, etc. for the last element got picked 3 times, right? This is one possible outcome, right? Can you like this, can you write another possible outcome? Of course we can. For example, we have the walls here. Another possible outcome would be, okay, for this time, element 1 got not so lucky. It hasn't been picked any time. So there is no circle here, for example. And the second element got picked twice. The third one got picked once. The fourth one got picked, for example, 5 times this time. And okay, this one got 2. And the last one got, for example, 3 times. Okay, this is another possible outcome. So the question is really converted to how many patterns can you write? How many patterns here? Now, how do you think this problem? Okay, the boundary walls on the left and on the right is always 2 walls, right? There are always 2 walls here. But for the walls and circles within this 2 boundaries, you can change their position, right? How many patterns are there? It could be, for example, wall, wall, circle, 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 wall, 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 circle, circle, wall, wall, etc. Wall, wall, circle, circle. Or it could also be wall, 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 circle, 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 wall, 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 circle, circle, etc. Circle, circle, wall, 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 wall. Okay, if we write patterns like this, how many patterns can it be done? So that means you have n plus r minus 1 positions. And within these positions, we choose r. We choose r positions to let these r positions be circle, right? So the problem is actually converted to, we choose r from n plus r minus 1. So the final result would be c n plus r minus 1 r. This is the total number of ways you're looking for, right? Do you understand? Okay. In a summary, when you do combinations with repetition, the formula is c n plus r minus 1 r. This is the number you're looking for. Okay. If you still not understand, I recommend you to read these references after the class. Okay, do the reference reading. Actually, this is the hardest part of Unit 1. You still can't understand, you just remember this formula. All right, okay. I'll set you an example to illustrate the application of this model. Okay, for example, if you walk into a candy store and have enough money for 6 pieces of candy, the store has unlimited chocolate, gummies, and horrible Chinese candy. How many different selections can you make? Okay, I'll give you 5 minutes to think about this question and we'll talk about the solutions after that. Okay, have you finished? I'll draw a diagram to help you understand. Okay, suppose we have a jar here, and we have C, G, and H in the jar. And the task is to pick 6 pieces of candies out of the jar. And for each time you pick a candy here, we replace the jar with the same candy you pick. So this is a typical combination with repetition problem. And n here, n is 3. That's the number of elements in the jar. R is 6. That is the number you pick out of the elements in the jar. N is 3, R is 6. And according to our formula, total number of ways would be n plus R minus 1 R, which is 3 minus 6, 3 plus 6 minus 1, 6. C8, 6. And we already know that C86 is C82, which is 8 by 7 divided by 2, which is 28. So this is a total number of ways you're looking for. All right, any questions? Okay, so if you have no question, we can make a brief summary what we have learned so far. So far, we have learned 1, 2, 3, 4, 5, 6 common, actually 7, right? 7 common counting techniques. First one would be rule of product. The second one is rule of sum. Third one is, okay, I'll use a diagram to illustrate. Pick R from n elements and line them up. That is P and R. The fourth one is pick R from n with replacement and align them up. Result is n to the r's. The fifth is to, okay, you have M1, M2, M3, Mk, and total number is n. This is called full permutation on a multi-set. The result is n factorial divided by M1, M2, Mk factorial. And the sixth one is combinations without replacement. The result is C and R. C and R is P and R divided by R factorial, which is n factorial, n minus R factorial, R factorial. And the seventh is to pick R from n with replacement. The result is n plus R minus 1 R. Right? Please do remember these counting techniques, as this is very important to calculate the probabilities.